What is up, everybody? In this video, we are going to learn how to read an analog input with the Arduino. We will use a potentiometer to read an analog value and control the brightness of an LED using an analog output. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our basic setup circuit that we made in an earlier video. Hover over the circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our circuit in the top left corner and change the name to LED-Analog Input. Select an LED from the components and add it to the breadboard. Remember that we need to have a resistor to reduce the current flowing through our LED. Click on a resistor, rotate it using the R key, and place it on the breadboard. Change the resistance to 220 ohms. Add a black wire that connects the cathode of the LED to ground. Last, add a yellow wire from the resistor to pin 3 on the Arduino. Since we'll be using an analog output, we need a pin with a tilde. Select a potentiometer from the components and add it to the breadboard. Change the resistance of the potentiometer to 1 kiloohm. The potentiometer in your kit will look a little different. Essentially, all potentiometers have 3 pins and a dial. Current flows through the potentiometer, and the middle wiper pin will be used to read the analog input. Turning the dial will change the value. Connect a black wire from terminal 1 to ground, and a red wire from terminal 2 to power. Up to this point, we have been using the pins on the Arduino that are listed as digital. They can read and write digital values, and write analog values using pulse width modulation, the pins with the tilde. Now, we want to measure an analog input, the potentiometer. So, we will connect the wiper pin to the analog in pins on the Arduino. Connect the wiper pin to A0 on the Arduino. Next, we will add code. Click on the Code tab and ensure the text drop-down is selected. Fill out the information in the header of our code. Update the program name and description. The program name is LED-Analog Input, and the description is a sketch where we will control the brightness of an LED using a potentiometer. Declare the variables. Create variables for the pins. Type int LED pin equals 3 semicolon to define the pin for the LED, and int pot pin equals A0 to define the pin for the potentiometer. Notice that the analog inputs on the Arduino have a letter A in front of them. Last, we will create a variable to hold the value of the potentiometer. Type int pot value equals 0 semicolon. In the setup function, tell the Arduino that the LED will be an output and the potentiometer will be an input. Type pin mode, open bracket, LED pin, comma, output, close bracket, semicolon, and pin mode, open bracket, pot pin, comma, input, close bracket, semicolon. First, we will read the value of the potentiometer. In the loop function, type pot value equals analog read, open bracket, pot pin, close bracket, semicolon, to read the potentiometer as an input. Below, add serial.println, open bracket, pot value, close bracket, semicolon, to debug. Click Start Simulation and open the serial monitor. As you turn the dial, you should see the values range from 0 to 1023. So what's happening here? The analog read function is measuring the voltage input on pin A0. The function converts the input voltage range, 0 to 5 volts, to a digital value between 0 and 1023. This is done by a circuit inside the microcontroller called an analog to digital converter, or ADC. So you might be thinking to yourself, if we want to control the brightness of an LED, we need a value from 0 to 255. but our potentiometer value is between 0 and 1023. Fortunately, there's an amazing function we can use called the map function. The map function remaps a number from one range to another. The map function has 5 parameters: value, from low, from high, to low, and to high. Below the line where we read the value of the potentiometer, add pot value equals map, open bracket, pot value, comma, 0, comma, 1023, comma, 0, comma, 255, close bracket, semicolon. Click Start Simulation and open the serial monitor. As you turn the dial, you should see the values range from 0 to 255. Awesome! Now we can use this value to control the brightness of the LED. Add the line analog, right, open bracket, LED pin, comma, pot value, close bracket, semicolon, to the loop function. Click Start Simulation and turn the dial. As you turn the dial, you will see the brightness of the LED change. We are reading an analog input, mapping the input to a value, and sending it to the LED as an analog output. You can also use the map function to invert the low and high values. We can do this by changing our to low and to high values. In your sketch, swap the values of the 0 and 255. Click Start Simulation. You will notice that we can turn the dial on the potentiometer, but we have reverse functionality on the LED. Turning the dial left makes the LED brighter, and turning the dial right makes the LED dimmer. At the end of this video, you should have a better understanding of how to read an analog input and use the map function to remap a number from one range to another.